Oh my god, my internet is really, really bad. Alright, okay, we are up. Oh, I pray my stream doesn't end abruptly while I'm working. Alright, so yesterday I started working on this two sum problem, and while I was explaining what I was doing, my connection got cut off, so I didn't, I don't know, I couldn't continue to the end. But today I'll quickly go over the solution and walk you through. So let me see. Let me remove this. This were the things I did yesterday. So I'm just going to quickly go on and take this out. Just put pass here. Yeah, for that error. Anyway, so yesterday I solved this question with um this was my solution, right? And this solution wasn't the best solution because um here we are running another loop inside the main one, which will cause us to spend more time on this operation, right? So this will have a time complexity of O of n squared, right? A loop within a loop will have a time complexity of O of n squared, but the space complexity here is is linear, right? It's O of n because we have an array here. So LeetCode, they were asking us to, you know, provide the best possible solution. When you read up to this point, follow up. Can you come up with an algorithm that is less than O of n squared time complexity? Um, Yesterday I was stuck providing that particular solution. So what I did was go to the editorial and read the solution that was provided. Um, so here is the solution and how I understood it. I'll use this board first of all to demonstrate what is happening. So we have, um, oh, sorry. Okay, so we have a, let me use this, where is it? Let's draw. Okay, so we have a list of numbers. I'll just use the one they used. I think it was 273 27 11 15. Okay, so 2 7 11 15, right? And the targets here, so I'll just put this as n, and the target t here is equal to 9. Okay, so what they're asking us to do is to return the indexes where two numbers, when added up, I mean, when you add those two numbers up, you get 9, right? So the solution here was to use a loop, right? The first solution I provided was to use a loop that goes this way. So I would loop through, select this first number here. Hold on. Why is the pen not changing color? Okay, the background. Okay, so my first loop would do something like this. So I would target the first item, which is I here, right? And then go through the rest of the item and perform the operation. So I'll do, number at I, n at I, which is this number here. So n at I. So I would select the first number, n at I, and then loop through each of the other numbers to see which one of them will add up to 9. So how would that happen, right? On the first iteration, I would say, okay, n of I, Then I will have another loop that goes through the rest of the items, which is, these numbers here, 7. So the second loop will target this one, I plus 1, because we want to take the next number, and so on. So if the first iteration, right, of I and j, right, I and j is equal to I plus 1, so which is this point here. If in this iteration we don't find any number that add up to 9, right, we'll then go back and increment I. So on the next iteration, after this inner loop is done running, I will now become 7 and j will become 11. So we'll still run the iteration, the loop, all over again. And this causes a problem, right? Because every time we do this, it doesn't favor us in terms of time. So because all the operation, n of I plus n of j is equal to 9 will always, happen for every inner loop and every upper loop. So this causes a problem in terms of time, and it is not efficient. So what they are asking us to do instead is to use a time complexity that is linear, O of n, right? That is linear, that increases just with the number of items we have in our array instead of the number of array and then a sub-array, right? Which is 2 loops. So what we'll do now is, first of all, we need to know what the next number would be, right? So let's take it like this. So let's say t, right, is equal to n at a particular number, let's say x, right? Or let me just, n at x plus n at y, right? This is an equation. Now, how do we get t? We just simply plot in, a number here and another number here, right? We represent these two by a number. This n of x is basically a number within this array, and this n of y also is a number within the array. But x here and y here, they are indexes of those numbers. And I explained yesterday that indexes start from 0, right? You start indexing items in an array from 0. So if we found a number at 2, it will be, index 0. A number at 7 will be 1, 2, and 3 here. So yeah. So already, let me bring back the equation again. N of x plus n of y. All right. Since we know that these variables here, right, are items within the array, what we can, since we know these are items within the array, we can easily, use any of these numbers here, right, to replace the first one. Okay, we can use any of these numbers here to replace the first one. So we can say this n of x, right, this n of x here, it could be 2, right, it could be 2, it could be 2, it could be 7, it could be 11, it could be 15, right? So once we have this, the equation becomes more easier. We already know t is 9, which is our target. 9 plus any number that we choose here. Let's say we choose 2, right? 9 is equal to 2 plus n of y, right, plus n of y. So 9 is equal to 2 plus n of y. So how do we find n of y now? N of y would be 9 minus 2, right? So which means every time we loop through the array, right, we loop through this, we are looking for the next number when added up will give us 9. And we also need to remember the indexes at which this number are placed. So to do that, we need to create a form of map for each number in the array against their indexes. So what I'll do is I'll say, okay, I have a map like this, and we have the first item will be 2, but let me just use a different color for this. Okay, the first item would be 2 to 0 to 7 to 1, 7 to 1, 11 to 2, and 15 to 3. So with this map, right, anytime we choose a number, we already know which index at which it is, right? So we can then easily return the index when we find a match for this particular y that we are looking for. So how do we do that? We first of all create the map, right? So we'll create a map like this, and then we would run a separate loop, right? We'll run a separate loop and find, so a separate loop will do this. So let me say loop of I in nums, right? In nums, let me just do loop of, let me just put loop I yeah, in nums, right? In nums. So what this would do is we'll say, okay, as we are iterating through this current loop, we want to also check against our map as well. So in our current loop, right, we'll say n of y, we'll call it n of y. If okay, we'll first of all make an operation, right? We'll say, okay, let's say results, right? Oh, sorry, we are looking for n of y. So n of y is equal to 9, right? 9 minus nums here, so I'll call this n of I, right? Now we'll check, is there any number, right? Is there any number that when we run this operation, right, n of I, does ny already exist in this map that we created? So how do we do that? We'll say, okay, n of y is equal to 9 minus 1. Then we'll say if ny is already in this list here, if ny is in map, right, is in map, that means we've found a match, right? Otherwise we'll keep looping through, and I will change each time we run the operation. So if n of I is already in the map, right, if n of I is already in the map, what do? We simply return the map, right? So we return map at n of y, because we want to return the indexes, not the item itself, and I, the correct index at which we found a match for ny, right? Now there is a catch here. As we are returning n of y, right, we want to make sure that we are not returning the same item at this index. So we'll say if n of y is in the map, and the index at which n of y that we found here is not the same as this I, then we can now return this. Otherwise, the loop will keep going. So if n of y is not, if the map at n of y, right, which is the index ny, is not the same as I, then we can now return this result here. All right, let's go to the code and write the code for that. What's going on? Oh, okay, sorry. This was my O of n squared operation, so we wanted something better. So first of all, let's create our map, right? I'll call this a map, okay, map, which is an empty map, and then we'll iterate over the items and add them to the map, right? So if for I in nums, right? For I in nums, let's not use I in nums. Let's use in range of nums, because if we use I in nums, we are directly getting the items themselves, but I want the items and their indexes. So in range, so we want to start from 0 and then up to the last element. So len of nums will automatically exclude the actual. So what this will do is, if the array was, let's say 1 2 3 4, this is 4 items in the array, but the last element will be at index 3, which is len minus 1, right? But already the range stops at len minus 1. It starts from 0 to len minus 1. So already range is already a good solution for us. So what we'll do is we'll say map what? We are mapping the item now, right? We are mapping nums at index of I is equal to I, right? Is equal to I, and let me just let me return this, or let me print this for you to see the map that I'm talking about. Let me just print map. Let me call this map X, so that we are not using some built-in keywords. I just want to be sure that we are safe. Okay, when I run this code now, you will see what will happen. We'll get our map. Type object does not support item assignment. What did I do? Oh, sorry, map X. Okay, so when I run this now, you can see we have 7, which is at position 0, right? Sorry, 7 is at position 0, 11 is at position 1, and so on. So this is already good for us. Now, what do we do next? We run a second loop, right? So for I, again, in range, I can still use range, or I can just use num directly. For I in nums, right? Let me use range still. Sorry, let me use range. Yeah, let me use range, because I also want to return the index at which this one appears. So for I in range, range len of nums, right? Len of nums. Now, what do we want to do here? We want to find n of y, right? So n of y, because in our equation we said n of y is equal to the target minus the items nums at I, right? So now what do we do? This is the last part of the equation. So if n of y, right, if n of y is already in the map here, So how do we check that? We'll just say if ny in the map, right, map x, and we also said there's an edge case because the current, we don't want to return the same indexes. So and the index at root disappears, right? So map x at index ny, right? Map x at index ny. So this, if we have 7, this will return 0. It's not the same as I, right? Then we can return. Then we can return the index of this item here, which is map x at ny and I. So this is our solution, right? This is all we need to do. And the time complexity of this is O of n, because it will take as much time to create this loop, this map here. This is O of n, because I mean it's just one operation that is happening here, and it is based on the length of the items in these nums here. And then the second one will be this one here. This is also based on the length of the array, the list, the nums here. So despite the fact that we have two separate loops, it is not O of n squared like this one here. This is not an effective solution in terms of time. It is not effective, but in terms of space, it is effective, right? It is in linear space, but this is not linear space because we are creating a map now. This is a separate data structure. A map will take space in the memory. So with increase in this map, we'll see an increase in the size of our memory. So this is not effective in terms of time. It is O of n squared. But in terms of space, this is not effective in terms of time. In terms of space, right? It's not effective. It's O of n squared. But in terms of time, it is very effective. Not very effective per se. It is effective. It is O of n, right? It is in linear time. It increases with the size of the inputs that we give it, which is nums, right? So let's run this in. Okay, let's see our solution. So we have 2 and 0. Why is that? Because I changed the position of this one here. So the first one is 0, is 2 because 2 is here. I just changed the position to see if that will work, and it works just fine. So let me run this and tell you this solution. Okay, we are here, and then let's run this code here. All right, so let's run this. Okay, this passes the test, and let's submit. That's it. So you can see in terms of memory, it's not doing well, right? It is 17.666, but in terms of time, it is really fast, right? We are using 53 milliseconds. If I had run the other one, yeah, I need to do that. Let's run this one here and see what happens, right? So I'll run this again just to see what happens. Then although I will not submit this one. So we have 53 milliseconds here and 17.66, right? So in terms of time, it is good, which is our previous solution. So let's submit this. We have 53 against 17. You can see. Now you can see our time has increased to 1000, which is really, really bad. It's so low, right? But in terms of space, we are doing well. Although it's still 17, but the other one was 17.66. This one is 17.38, which is nice, but that's the catch for this kind of problem. One has to give up relevance for the other. All right, so that's it. This is the solution we are going to go with, and we'll stick to this because this works well, although the space is not really given. All right, now let's go on to the second one. We want to do contains duplicate. Okay, contains duplicate. Let's go to LeetCode 127. I don't want to open my browser. Yeah, I should have had the Google search. Yeah. How do I do this? I don't want to show my browser. Insert link, copy format. This is embarrassing. Anyways, I'll duplicate this. I just want to keep that there. Run this one here. Contains duplicate. I already solved this question, but you see something. Okay, I already solved it. Well, let me remove this because I saw this some time ago. It's been long. But I'll remove it and go over the solution. Now, what's this asking us? It said given an array, an integer array, right? Return true. An integer array norms. Return true if any value appears at least twice in the array, and return false if every element is distinct. So return true if there is a duplicate, but return false if there is no duplicate. So in this first case, we have 1, 2, 3, and then 1. So that is a no-no, right? That's a no-no. When we have 1, 2, 3, 4, this no duplicate, so we return false. 1, 2, so you can see already we already have some duplicates here, so we'll just return false at once. Is there any follow-up question? Yeah. So I've seen it before. I've seen this question before. So let's solve it. Let's solve it again. I like it. All right, I'll call this one here. Maybe I'm just not doing this well. So I'll call this contains dash duplicate, right? And what I usually do is I'll always take the two test cases. So I'll say for this and that. So let's just use one of our arrays to do this. I'll just copy this here, paste, and take this out. Oh, I didn't copy the function. You know what? I'll just solve it here, right? And then when I want to share the link on GitHub, I'll put it in my code editor. The time is running. I've already done. It's me. I'm spending time. Sorry. Let me not put the blame on anybody. All right. So, yeah, we want to check if there's a duplicate. What do? Now, you can see there is a pattern here. I already recognize something. You remember how we did map here, right? How we used map here to find okay, let me just do this. How we used map here to map each item in the list, right? What if we use that same map, right? But this time around, what we are using the map for is not to get the index, but to get how many times it appears in the list, right? So what I would do is, so anytime I see an item, I will increment how many times it appears in the list. So let's say we are doing, let me just clear this out. Oh, so we have an array, n is equal to, the first one is 2, let's just use anything, 2 3 2 5, right? So I'll create a map, right? I'll look through each one of these. I'll create a map. Let's call this map is equal to this. So is equal to an empty list. So each time I iterate through this n here, right? Let me just say nums. Each time I iterate through these nums, I'll set up the map, right? So I'll do this. I'll say map now will look something like this. Map now will look like 2. Then how many times have I seen 2 so far? I only seen 2 once, right? So 2 will be 1. The next time I loop, I'll say 3 is what? 3 is also 1. 3 is also 1. And so on, right? Now, the next time I'm looping again, I'll check, okay, do I already have 2 here? So every time I'm looping to map each number in this map, I will check if the number already exists, then increment it if it does. Otherwise, I'll just set it to 1, right? So if the number does in fact already exist, what I would do here is I will just say 2 plus 1. Now this is already 2, right? It means this 2 here, we saw it twice in this list, and what we are looking for is how if any number at all appears twice in the list. So since we've seen 2 twice here, we just simply, we just simply return true. We don't even need to bother going further and checking if 5 also appears twice or if there's another 3 here. So let's quickly get to the code. I'll say, so like these are recognizable pattern. We used map before, then we are using map now again. So always remember patterns. I said I'll solve it in the other side, so let's just go to LeetCode and solve it there. In the real interview, I think we're probably going to solve in LeetCode, so why not? Let me just close that. So what I would do here is I'll say we have a map, right? Let's call it hash map. Hash map. Oh. Hash map is equal to an empty dictionary, right? A map is basically a dictionary. So let's use an empty dictionary. An empty dictionary. And then I will loop through the norms, right? I'll loop through the norms. For I in... Now, I don't want to use indexes. I don't have anything to do with indexes, so I'll just use the item itself. For I in norms, right? For I in norms, what I would do now is I'll say, now first of all, I want to check, does this number already appear in the map, right? Before I would then, go ahead and do sub operation. Now, if I not in map, hash map, right? If I is not in hash map, what do? We just create a map for I, right? So we say I, oh sorry, you see, let me not go and misspell this thing. Hash map is hash map of I, so of I, right, should be equal to 1 because it appeared 1. Now if we see, if I already appears in the map, so what do? We say we just say, okay, I is already there. So what do? We just say um hash map hash map hash map of I. There's no auto completion, is this? Hash map of I plus equal 1. So meaning we are increasing the previous value, and then we just return true, right? We just return true. We don't need to, you know, go ahead and check if there is already um it has a value of 2 or more than 2, blah blah blah. We don't need to do any other operation. We just return true. Otherwise, if there is no uh item and we are done looping through this, we just return false. Return false here. Okay, let's test this. This is quite easy though. Yeah, so let's submit. And wait, before I you know see the submission results, we need to test our we need to do the space and time analysis. So what do you think is the time analysis and space analysis here? The space complexity of the space and time complexity, what do you think the values are? Is it better in terms of time, or it is better in terms of space? The answer is it is better in terms of time. It's better in terms of time because we are just running a single loop, right? But then in terms of space, we are also creating a hash map, right? So this is not going to be good in terms of space, but in terms of time, it is better. It is that's like the worst we can have in terms of time. That's the worst possible case. O of n. Well, both of them suck actually, but you can see that the time is better than the space, right? Um, hmm. This solution is accepted, but well, both of them suck. Sorry, sorry. Let's contains duplicate 3 and 2. Let's not deviate from the main solution. Let's look at the editorial and see what we did wrong. Oh, payment. We don't have money yet. Oh, one day we'll be able to see. All right, your last submission is 26% of submissions wrought time. Well, 26% is really bad. It is really, really bad. We don't need to see 26%. We need to go at least above that. Our solution works, but it sucks. It's not the best. So let's see who has a best solution. I'll just use Python and see, okay, and see this. Okay, so it's using sorting approach. Interesting. So he sorted the you see, we are not using any built-in methods. So I mean this works, but well, because it has so many upvotes, it has about how many thousands of upvotes. Okay, he's using a hash set. A set. And he's doing scene and oh, I see. So a set basically returns unique items, right? So for every number that is seen in a set, it will return true because now this number appears there. I see. This makes so much sense. This makes so much sense. And let's check the time complexity for this. I'm just curious, right? This will be O of n. I don't know why this is bad in terms of time complexity. Right, so let's see. Let's submit this. It's still not good. But in terms of space, it's not using any other space. It's still not good. It's 19.8. Well, he beats us, right? He beats mine. Beats mine, sadly. Sadly. Let me see. He's 19.8. Sorry, submit. What just happened? My solution was actually good. Did I not run? Wait, what's going on? This. Hey, hey, hey. I said it. My solution is good. So, kudos to me. What happened? What happened? Because it just went all the way. Before he was saying it's poor, now he's saying it's good. We did well. Okay, so the next one is contains single number. Oh, we're running out of time. Let's quickly solve this one too. I'll just go through again. I've never solved this question, by the way. I don't know what it is, but let's see. Let's see. Contains single numbers. Contains single number. I'll see if I can solve this in less than 5 minutes. So, given a non-empty array, just try. I don't know why LeetCode does this. You're just trying to confuse people. Given a non-empty array of integers, every element appears twice except for one. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. Constant, that means no O of n self. So we are just saying, oh, this one. How do we do that? I was thinking we'll still use the same pattern. Use a hash table, right? Find, iterate through the entire list, map each one of them, and then just look at which one inside the list has a length, a value of 1. Inside the hash map, which one has a value of 1? Then that's the solution, right? That's the solution. That would be the solution. I'll go back. Oh, I didn't copy that other value. Will I still have it there? I'm not sure. Hey. Okay, let me copy it here so that I can post it on GitHub and share the link in the description. Well, we still need to import this name because we are using types. Awesome. Let me put this here. The second one, this will be new what? Creating a new file. So we'll call this what's the name again? Single number, right? Single. Let me just confirm. Single number. Hey, watch the time. We've already spent 2 minutes out of the 5 minutes I proposed. Yay. Let me see. Okay, so single number. This is, yes, single number. Christ. Need to stop doubting myself. And trust. Single dash number. Same pattern. It's always repeating. I'll still use the same hash table. Constant space. How do we do that? Constant space is O of 1, right? It means we don't have to create new memory in space. New space in memory. So what do we do now? Because I was thinking we'll use a hash table, then just go through and see which one has a value of 1. But now they are saying we should not use that. We shouldn't do that. That is bad. So I don't want to use any built-in method. I always need to do stuff by myself, right? What do we do? I can't think of any other thing because this is a pattern that I recognized will work for this. Let me just get on. A hash table. You can call it hash table, hash map. It works, right? It always works. So what do? We just loop, say, for I in hash table, right? Hey, sorry, in DOMs. Oh god, I don't like. Right, for I in norms, just do hash table, hash table of I, right, equals 1. Oh, I'll say if I is already in hash table, right? If is already in hash table, what I'll do is I'll just do hash table, hash table, hash table incremented by 1 plus equal 1. Otherwise, we just add a new hash table. Then I'll just say this is still a loop, right? So I'll say return, you know, which number has. So return. I want to write a single return statement. So return hash table. See, I misspelled it here. Hash table. Okay. I wanted to use lambda function, but I guess I've forgotten how to do that. Anyway, so what what I'll do there is just run a second loop and say, okay, for I, or let me just use J in hash table, right? Want to see which one has a value that is, superior to 1. So return hash table. No, we want to return the one that is equal to 1. Hash table at J, right? It will get that the current element. Hash table at J that is equal to 1. Sorry, that's equal to 1. So yeah, is because this is a non-empty array, so there's always going to be an item that appears only once. That's what the question is saying. Otherwise, we'd have added some edge cases here. Okay, let's see what happens. Okay, I knew something was going to happen here. So hash table, at I here. All right, I know what that is. Oh, spelling mistake. Oh, wow. Hold on. Oh, return hash table I if this is equal to 1. Is this a valid, or do I need to add else? Yeah, expected else after this. Oh, let me just do it this way. I'll just say return this hash table here like this, and then just indent this one. Yeah, that will work now. I think this will work. There's a wrong answer. Which case is that? The hash table j is equal to 1 and is returning 1. Why is that? For I contains duplicate hash table. You see, else, because this is not good. This is not good. This is not good at all. Wait a second. What did I do wrong? So we have, this is returning 2 now. If I, you know what, let's first check if it is not in hash table, right? Let's set this equal to 1, else I plus 1. Oh my god, we have just 15 minutes left. I have 15 minutes left. If hash table, a hash table works. I know that for sure. I still don't see a reason why. Okay, let me see. Hash table I for j in hash table, right? I'm returning hash table. Come on. I'm supposed to return j, not the hash tables I. Yeah, it works. Oh, this will not be good in terms of space, but in terms of time, it works. You see, this is what I don't like about. If I wrote this again, this will probably like go up a notch. Let me see the editorial. No solution. Wow. Okay, 35%. And this says what? X and O, because they said S and O operation. What's S and O operation? What's that? What's S and O operation? Duplicate. I don't know what it is. What does it mean? A logical. Ah, wow. So S and O is a bitwise operation. Let's see how they did it. S and R operation, blah blah blah. This guy just straight up went coding in. Can I share my solution? I can't. I can't actually. I can't. I can't even do anything. I can't share my solution. What does this do? Python 3. Let's see. Python fanboys. Let's go. Let's go. Oh, reduce C lambda function. So what this does is it just chooses. So the reduce will return a single number. And this says x and y. What's x and y? X or y nums. Interesting. Interesting. He didn't explain his solution. That's what genius people do. Okay. We are blasting through. We are going through this, which is awesome. Okay, so let's say merge sorted array. Practice question. Merge sorted array. I think I've solved this question before. I'm not sure. But let's see. Yes, I've solved it before. How did I even solve this question? I don't. Okay, it's an easy question. Let's use a plain mind, right, to go through this. You are given two integers array, nums1 and nums2, sorted in non-decreasing order. Non-decreasing order, that is increasing order, so from small to big. And two integers m and n, right, representing the number of elements in nums1 and nums2 respectively. Merge num1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead to be sorted inside nums1 to accommodate this. Nums1 has a length of m plus n, where where the first m element denotes the element that should be merged, and the last n element are set to 0 or should be ignored. Wait, I saw this question before, and I'm sure I just did something there, and I'm not making up excuses, but let's see. So you are given two arrays, n and m and n. So they want us to sort in non-decreasing order. I'll do this, right? I like to sketch, I like to sketch. So I'll say this here and put this here. Okay, so we are given two array. So here we are given two arrays, right? Num1. You know what? Let's see the solution, the input cases. So we have nums1, 1, 2, and 3, and then we have 0, 0. Nums m is equal to 3. Nums2 is 2, 5, 6, and n is equal to 3. Okay, so the same merge m and n, right? This is like where the key information is. Merge m and n into a single sorted in non-decreasing order, single array sorted in non-decreasing order. And also the final sorted array should not be returned by the function, but instead stored in a nums array, right? Nums1. Okay, to accommodate this, nums1 has a length of m, where m is the first element. Okay, denotes the element that should be merged. So n denotes the element that should be merged. So for this nums1 now, m is 3, so 3 elements should be merged. So what we'll do, we'll have something like 1, 2, 2, because we'll do 1, right? We are merging everything inside of n nums1, right? We are merging inside of nums1. We are returning nums1 and not nums1 plus this, because at the end of the day we want to only have items from this, which is 3, and items from here, which is 2, 3 as well. So we have 6 items. We will ignore these ones. So So first of all, we need to insert. We should just assume that n of num n is our base, right? And then we'll each time look here and find where we should insert num the items in nums2. Then once we are done inserting, we'll just ignore these ones. It can still be there, right? Or we just remove them, but hey, we are just looking for 3. Let's see the another case. Of 1. Okay, let me try a brute force solution. All right, let me make my opacity. Okay, let me use a bigger pen. All right, so we have nums1. Hey, what did I just write? We have nums1, which is equal to 1, 2, 3, 0, 0, 0, right? And the amount of items that should be, added into nums so that we sort it is m, which is equal to 3. Then we have num or 2 is equal to 2, 5, 6. 2, 5, 6. And this has a length of 3 as well. We want to return nums1 to be equal to 1. Then we start from here. We should always, since this is a sorted array, we should just assume that, okay, already we have n, right? That is our first item in the array, because we are not merging into a separate array. We are merging inside of nums1 here. So since nums1 is already in non-decreasing order, which is sorted, then we just assume that the first item in the list is already in the right position. Now what we need to do now is we have to compare these two, right? We have to compare these two. Are they in the right position, right? We have to compare this one here against the second one here. Sorry, let me do it this way. We have to compare these two here against this one, right? Is it superior to this, or inferior, or equal to it, right? If it is superior to this, then we skip this one and check the next one, right? And check the next one. If it is not, then we'll have to insert it here, right? Between this and that. Or if it is equal to it, then we just choose the next index, right? So we add it here or anywhere at all. But it just has to be, either before or behind. So how do we do that insertion? Because for the first item, right, we know that this is already sorted. This is in increasing order as well. So we don't have to come and check if 5 has a position where we've already inserted 2. So we just need to continue the iteration. Okay, what if we do it this way? We see we can check the first item, right? Let me give myself some more time. I'll just give myself another 15 minutes. Cancel OBS. 15 minutes more. Yeah. So close and let's work with time. Ended. Sorry. Okay. So here's what we are going to do. We'll use, you know, we'll check. Okay. Um, we are currently at this position, right? So this is the first item here. Okay. This is our first item. This is our first item. We can see, we can check. We already know this item is in the correct position, so let's not even bother. We'll start from norms where I is equal to 2. So we just where I is equal to 1. So we start from 1 here, right? We'll start from 1. We'll compare it with this one here. We'll say, okay, is norms 2, right, bigger or, you know, superior, inferior to this item here? Is it big, superior or inferior? If it is superior, right, we move to this one here. We increase this. Let's call this x. X is equal to 1, right? We'll check, is x here superior or equal to the item inside this one? Or let's call this one self y. Y and x. Okay, we'll just do a lookup. So say, is y here, y is equal to 0 here. So is y here superior or equal to x here, right? Is it superior or equal to x? So we'll say no, because it is in the middle, right? But in the case where it is yes, it's superior to 2, then we will increase x. We'll move x to this point here. We'll check again, is this one still bigger or smaller than this? But in this case, we are okay. So it is not bigger than it. So we say, what is y superior to 2? No, it is not. So how do we insert this here so that we end up with something like this? 1, 2, 2, right? That's interesting. So to do something like that, hmm, to change an item in, want to insert it in the middle here. Well, I guess I would just have to do, okay, we'll say, we don't want to replace, and each time we, when we stop at a certain point, let's say we already did this insertion here somewhere. After inserting, we need to move, uh, so we ultimately, whether it is superior or equal, we'll need to insert it here. Otherwise, we insert it in front if it is smaller. Okay, so let's do it that way. So we'll say num 2 at x, right? Num 2 at x, and num 2 at x plus 1, right, is equal to, so we want to keep this one here, is equal to, wait, how do I say, we want to insert b in between. Probably spent enough time thinking about this. Num 2, num 2, we have num 2, I'm not sure, how do I, wait, because if I said num 3, right, wait, I'm inserting, I can't say num x plus 1 is equal to this. That means I'm just discarding nums x plus 1, which is 3 here. I'm just replacing its value. I want to replace it and have it in a separate position. Oh, I'm stuck. Yeah, let's take a look at the solution. Oh, you guys. What was my solution before? What did I do? Yeah, I want to see my solution. What was it? I'm sure it is still around something like that. Right. Okay. I say end num is m minus 1 and end of this. So we are choosing n. So I'm starting from both ends. Okay. I'm starting from both ends. So why n of num 2 is superior or equal to 0, right? If end of nums superior or equal to 0 and wait, what's this? Let me just copy this and see in my code editor. Oh, what's the name of the solution again? Merge sorted array. Merge sorted dash array. Honestly, I can't even believe I solved this before and I'm stuck now. So if end of num is superior or equal to 0, so that's num1. End of num1 is like the last element in num1. Okay. So it's 3, so that would be 2. Okay, we are taking both ends from here and here, right? So what are we saying? Oh, num of last merged m plus n, that would be 2. I still don't get what I did. So m nums 1 last merged end nums 1 end of nums 1. You see, if the first end that we took, right, which in this case would be 2, right? Let's say which arrays are we using? This is still not clicking. Is superior equal to 0. End of num1 is equal to 0 and num1 and is superior to num2 end of num2. Okay, so I'm already checking if the current, so we are using num2. Okay, end of num2, num1 is superior or equal to 0, or last merge end mn m plus n is equal to -1. So if this is 3 and 3, this will be 2 2, and this will be 4 minus 1 4 minus 1 2 plus 2 No, this will be 6. We are still using 3 3, right? 3 3, that will be 6 minus 1, that will be 5. So last merge end will be 5. So we are using last merge end, and last merge end would be what? So what am I returning here? I'm saying nums1 last merge end is equal to nums1 end of num1. I don't get it. I don't get it. Where did I even see the solution? Ah, this is crazy. I'm not even thinking about the question right now. I just try to, get the solution, which is really bad. Um, so we are inserting from the end. We are comparing the end. That will still work. That will still work. But so if we have to end of num1 2 is superior or equal to 0, which means it has already reached here or is at the start. So let's assume it's at the start. And nums1 end of nums1, right? End of nums1. So we are also taking the last one of end of num. So we are taking these two. Okay. Nums1 end of num1 is superior. So if the last item in num1 is bigger than that of the last item in num2, right? Then we want to do something. We want to do num1, the last item of the num1 should be the first item at the end, so we know that. And then we just say end of num1. So we already inserted that we increase we move the end. Oh, okay. Then what are we doing with this last merged end? Okay, so if it is okay, the current pointer, I see. So num1 last merge end oh my god, 15 minutes has gone. Num1 last merge end is equal to num2 end of num2. Let me increase my time again to script. Give me 15 more minutes. So okay, I see what is happening here. So if we've not reached the end of num1 yet, and the end of num1 is superior or equal to 0, that means if we've not reached the first item in num1, right? Num1 end of num1 if it is bigger than the item at this end, which is m minus 1, right? The second one, m minus 1, then we just want to keep num1 where it is, right? We just want to keep it there, and then move to the next one and check, is this one superior or equal to that? So if it is not, I was saying this before, so nums1 last merge end should be equal to the end of num2, and then now we'll now move north to the. This is all I needed to understand. I could still assign the item, right, and not lose the value. Oh, I see. You know what? Let me do this again. Let me go back to my board. Let me go back to my board. Let me go back to my board here. I'll just do this. Wait, let me bring back my board, in fact. Oh, I've messed up. But it's okay. No harm. We are learning. Alright. So I need to remember the last time I made a replacement, basically. Because here, what I'm doing here is I'm going from behind, right? I'm using the back, but I can still use the front. That sounded weird. I can still use the front to make my comparison. Here, I'm just checking if I've already reached the start, right? If I'm already at num 0. Otherwise, if I'm not, and the current item is superior to uh, the current item of num2, right? If it is, then I keep my item there because this is the one we are using for our merge, right? We are using this to merge into, okay, so M is the num1. So we are using this, so we keep our correct item. If it is not, if it's bigger, if it is bigger than num2. Otherwise, what this is saying is, if it is less than num2, we keep it. Oh, I see now. I understand. I understand. If it is less than num2, we keep it there, right? And then we just increase, you know, the position from which we are trying to make the insertion. And every time we make this insertion, I'm coming. Give me 15 minutes. Sorry, staying. I locked my door. All right. So yeah, each time we'll make this insertion, right? Yeah. So every time we'll increase this, but when we see a value, we'll keep it at the last merge end. The last merge end is already, at the end here. We already, oh yeah, we already know that the last merge, whatever happens, the total amount of elements that will appear in n, that is an actual value and not 0, will be, you know, even if it's still 0, but like we are just ignoring any item that is bigger than the value of m, right? So yeah, so end of num1 minus 1. So what I'm just saying is, well, I'm just going to reduce num1 and come to this side. I already know that that comparison is done. Okay, I understand this one now. Sorry, I understand this now. And what I was confused about is the insertion part, because what I was saying basically is still the same, right? It's still the same. And yeah, so we always need to remember the last time we made an insertion. Last merge end. Okay, so let me go ahead and still explain what is happening. I'll delete this here. Oh, sorry. And then I'll come back here and take this pen, this beautiful pen, by the way. So what I'll do is I'll say here, let me use this one. I'll say nums1 is equal to what? Actually did way better with my solution. Oh, the solution was here. And I still can't remember what I did. This is crazy. but yeah, it's okay. Okay, so num 1 to 3. Okay, 1 to 3. So we have 1 2 3 somewhere. I'll just put this here so that I can see it, right? So this is 1 2 3, then 0 0 0, right? And then num2, so num2 will be, these are just array questions, right? It's assumed to be this a simpler question, but anyway, we have 2 2 5 6 now. Okay, so what's going to happen? We want to merge based on a certain amount of item inside each list. At least for this one, which is the most important one, this is m. M is equal to what? Is equal to 3, and this is equal to 3 as well. N is equal to 3. And what I was saying is I'll have x, right? So I'll say the last time I made something, right? I'll call this lx, right? The last time I made a comparison, I'll just say set this to 0, which will be the first item here. Automatically, this item is the first item, so I don't need to even make any comparison here. So I'll start from the second one and see if it is the same, right? If it is the same, then I just continue with the merge, right? So what I'll do is I'll increase to the next one. I will not even mind, right? Because every time the loop is done. So in what situation, right, do I need to keep the loop going, right? What is the let me put this back here. I'm done copying. What is the the terms at how much of how long should my loop run, right? How long should it run? Now, this is a good question. We don't have to go all the way here, right? We are merging the items into this list. So how long it should run is based on the indicator that was assigned to this. So my loop should run m times, right? M times. And we are not going to reach the end here. So so I'll just say this is the end. Let me call this the end. Okay, let me just say, I'll just say loop through m minus 1 times, right? So we are going to go 0 1 2. M minus 1 will give us 2. So we are looping a total of 2 times, which in reality it's 2 times in computer language. Otherwise it is actually, I think it is 3 times, sorry, in human language. Okay, so now while we are in this loop, what do we do? First of all, we need to compare, right? We need to see the first item of this, the second against the first item of this. But I've already said that we're going to skip this, and we will just start here. We can skip this because this will always be true. We want this is in a sorted order. This is also in a sorted order. We don't want any confrontation here. So here's what we are going to do. We are going to say, well, since they are all the same, right? I can say if, right? So I'll just say I here. Let me call this one here. Let me say I, or let's say n1 is equal to 1 and n2 is equal to 0. Yeah. So if n1, right? If n1 or num at n1, right, is is, you know, bigger than this one here. If it is bigger than it, then we want this one to take position. So if it's bigger than n of num2, right? Num2 n of 2, right? We'll just do the, what am I doing? First of all, relax. Okay, yeah. So if it's superior to m2, we want to take this here. If num of 1 is superior to this, then if it's bigger than it, what do we do? Then this becomes our, you know, last end merge. So this is 1, because the last time we're starting from here, right? That will be our last end merge. So num 1 of our last merge end, last one, should be equal to num 2 of n2, right? Otherwise, if it's not the same, we want to keep this here. So we'll still say the last of num1, right? We are merging into num1. Num1, the last end of num1, it should be equal to num1 n of 1, right? So yeah, and every time the loop goes on, we need to increment the last end, which is we need to increment this one by 1. So yeah, plus equal 1. What am I doing? Plus equal 1. Yeah, okay, this is clear now. Yeah, I know what I'm doing now. Okay, num1, num2. What's the time? Oh, I've already done so long. Yeah. You know what? Let me just quickly code this. Write the code here. Let me just remove this too. I'll comment it out so that you know that's my previous solution. So now I need to start from the start, right? I'll say n1, right? N1 should be equal to, you know what? Let's start from the beginning. N1 is equal to 0. So does n2. N2 is also equal to 0, right? N1 is equal to 0, N2 is equal to 0, and then the last merged, last underscore, last merged is equal to 0 as well. So we are starting from the start. Although we know it's not supposed to be like that, this still works, right? So we say while we still have our n1, right? And n1, we don't even, do we need, okay, we need these values here. Which one belongs to num1? Okay, well, this is tricky. While m is still superior to 1, right? We'll do it that way because we want to stop at 0. Is superior to, wait, what am I doing? I need a proper edge case for this. You know what? I can still. I always want to. Okay, let's. This is horrible. Well, I'll just say n3 is equal to m minus 1, right? So, no, I'm increasing. Sorry. So, I can still do this. While n1 is less than m, right? Is less than m, we want to do something. So, this will happen in the other direction. Okay, this is good already. So while n1 is less than m, we want to. Oh, I have 16 people. Oh, the time has elapsed. You know what? I'm just starting. I believe. Don't feel bad when the time has gone this this far. So I promise 15 minutes max we'll finish. Um. So while this is less than that, while we are still at the start, right? We're still targeting the first item in the list. We are still at 0. We want to compare, is item at 0 superior to item at 0 of the other one, right? So what do? We say if the norms norms 1 of n1, which is 0, if the first one, obviously it is, but let me still do it that way, is superior to norms 2 n of what? n of 2, right? If it is superior to n of 2, then what will happen? We keep our our item at the same position. So we say norms 1 at the last merged index, right? At the last merge, let's call this last merged index, last merged position. Let's just put position there. Last merged position, so that it makes sense. Last merged position is equal to what? Is equal to the first one. So it's equal to norms 1. Sorry, norms 1 at n1, right? Then what we'll do is we increase norm 1 by 1 because we want to check the next item now. Sorry, plus equal 1, right? Now else, if it is not, then what do? We know now that okay, this one is not equal to that. So num2 now, right? Nums2 at n2, right? n2 will be equal to no, nums2 at last merge position will be equal to, sorry, nums1 at the last merge position, nums1 at the last merge position will be equal to nums2 at n2. Yeah, then this time around it is n2 that we are increasing. N2, okay, n2 plus equal 1, right? And then we always have to increment this last merge position despite whatever happened. So last merge position plus equal 1. So this is it. It's similar to this one, but yeah. So this is the solution here. This is 0, sorry, 0 0. Okay, let's run this and see if this will work. Right, merge sorted array. See, stop that in yourself. Oh, okay, let's run this. I hope it works. Okay, it's not working. What happened? It says what? Index out of range. Okay, what's happening here? Well, we are saying n superior to 1, right? We need an extra edge case here. We are saying, you know, um we can only compare, right, when we are still not at the end. Although this is saying, yeah, we still need to check this. And we want our entire array, right? Our entire array to be the size, our entire operation to be the size of n plus 1, n plus n minus 1. So that's 5. Yeah. Well, if this is that, and we are always incrementing this, the next time we check this, right? Let's see. Let's first do that. If n nums at 1, nums 1 at n1 is superior to the value here, is less than this value, is less than m. Yeah, this checks that, but it doesn't, do this. And this, right? Let's see. Wait. We're at 0, 0, right? N1 is 0. Okay. Let me just use N1 is 0. Oh, it's less than n minus 1. Sorry. This is. Nah, that's not it. Wait, we are checking if nums I n minus 1. So this will be 0. So at 0, 0 is less than m. M is 3. We don't want 3. We want. How is this out of range? Oh, okay. It is this one here. Because I'm already checking. Okay. N2. Because we are incrementing N2 each time. So if N2 is still within range, right, which is in the range of n minus 1. Yeah. Let's see. Okay. This is still not working. Nums of 2. Sorry. Nums 2, N2, n minus 1 is less than n. Sorry. N. Okay, I give up. What am I? Oh, I didn't put it 2 here. I didn't put 2. We are checking for 2. So let's see. What's going on? This index out of range. Oh my god. I streamed for almost 2 hours. This is not good at all. I still want to go from the front and not behind. What I'm saying here is superior or equal to 0. So is less or equal. You see, the problem is not this, right? it is by how much we are increasing it. So if n2, right, is still less than the m, right, or the n, yes, if n2 is less than the n and this is superior to that, then to increase this at the end of the day. But once this hits this condition and returns true, the loop will stop. It will not even come here. But as long as this is true, this should work. Okay, now it's saying last position. Okay, this is where the error is now. Last position at 1. Well, we are increasing this, right, each time, regardless of what is happening. So this index 2 is still out of range. Nums 2 and 2. Because this is increasing faster than any other one. Well, they are all increasing at the same rate, but there's condition to each one of them. There should be a reason why this increases. Well, this would have been 5. Because I always want to remember the last position at which I made a replacement. So if here we made a replacement, that means okay, the last position should not increase more than more than n, right? So if Bombay. Yeah. Why is this increasing faster? We started from 0, right? So for the first element in the array, we will go 0. It's saying it's out of range. It's impossible. Even if it's the first item and we I don't know. Oh, the time is up. The time is up. The time is up. This is blowing my mind. But anyways, I don't know. Why would this increase so fast? That is already, so we are saying n plus 1, right? We are only making a comparison here. If n plus 1 is less than so the problem is still here. Okay, we can't do it there. We want to do based on this m here. N2 is what? 0 0. We increase, first iteration will be 0 0, and then this will be 1, then this will be 1, this will be 1 1 2 2. Let me see what the issue is. I need to check this properly. Let me put in my code. Oh, it says what? Oh, sorry. Um, I don't know. Something is wrong here. Right. Let me see what other people are doing. Editorial solution. What did I click on? Python. They are using traverse through, append its element to the end of num1, starting from index, and then sort the entire array. Nah, don't want to do that. That's feels like cheating, right? So what he's saying is add every other element. M plus J will basically add items to the end of this array, and then he's sorting it. This works, but it's not really um, a good solution for me. I mean, it feels like I don't want to use any built-in stuff, right? So yeah, using 2 pointers. Yeah, he's also going from the back like I did before. I don't want to go from the back, I want to go from the front. But if I understood that the front, if I understood the front solution, then where am I going? Why am I getting stuck? Will the length of M and N always be the same? It won't be the same. No, it will not. It will not be the same. It will not be the same. Mm, mm, mm. Okay. You know what? Let's end this. I don't. Okay. You know what? Let me not give up. Right. Let me think about this. Despite the fact that this stream ended, I'll still think about this properly. If this is saying this index is wrong, that means we probably crossed this, right? We've gone over this. So if Although this is like very bad code. But let's see if n2 is less than um, n, then we can do this. Sorry. Oh, what's going on? I hope. Oh, we. Wow, we ended up in an infinite loop. Oh, time limit exceeded. This just ran forever. Uh, you know what? Let's think about this properly. Maybe the best way to go about it is from the end, but let's just walk through how the end solution works. Right, so the end solution is saying I need to compare the last item of each array, right? So I'll say do not return anything on, yeah. So I'll say we want, the end of num1. So nums1 end, right? What is the end of nums1? It is m minus 1, right? M minus 1. The end of num2, nums2 end is also n minus 2 minus 1, sorry. So these are both ends of these two arrays that we want to merge. Basically, these are the these are the indices of last items index of both arrays, right? And then we want to know at what point we made uh, a substitution, last merged index, last merged, and we say this is equal to what? It's equal to the sum of both minus 1, both ends minus 1. So this will still give us the last item of the overall of the overall, how do you call it, the overall sum. Yeah. So our while loop is going to start from the end of, from one end here. I'll just use num1 since it is the one we are trying to use for our merge. So I'll say num1, and I feel so dumb right now. If it is superior or equal to 0, right, we want to do it that way. Then what we'll do is we'll now check if this current end is it bigger or less than the end of this num2 here. So nums1, if nums1, right, the current end, let me see, nums1 end, yeah, is it superior to the end of nums2, right, and is it bigger than 0 as well, because we don't want it to, we want to shift behind. This is like a double pointer solution. Is superior to nums2, nums2 nums2's end. We'll just take this one, nums2's end, and it is not behind 0, superior or equal to 0, right? If it's like that, then what do we do? We'll just do this. So I really struggled today, honestly. We'll just say nums1's end, nums1, nums1, nums1's end. No, from the last time we batch, because this should be the entire length of our array, right? So this will go to the end of the array. Last merged, right? Should be equal to. If it was in an interview, I probably have failed, and they will just. Anyway, we don't lose hope. Okay, so it's equal to nums1, right? And here. Now, once we do that, we want to come to the next one. So we'll do nums1. Okay, let me just do it this way. -1, right? So minus equal 1. Else, if it's the other way around, if it is the second array's last element that is bigger than the current elements that we are checking in nums1, then we'll just do nums1 at the current index, right? So at last merged is equal to nums2 last, the end of nums2 end, right? And then now we'll just do nums2 -1. So let's change this to nums2 here, and then we can just say last index regardless of what happens, minus last merged -1. Right, so this is the solution basically. So let's run this and see. It says what? nums1 and nums2 end. What did I do wrong? It's out of range again. It says, you know what? Let's first do this. If this and then that, right? If nums1 end, right, is still superior or equal to 0, because we don't want it to be more than 0, then nums1 end is currently bigger than, yeah. So how about that? What's the matter? I don't know. I think let me check my solution again. I have end of we are merging nums2 inside of nums1, right? So we are just going to use the index of nums2 to do the operation. Right. Oh God. God have mercy on me. I need to do better next time. Let's run this solution and see. I'll solve this as many times as I can, just to like have a muscle memory and recognize this pattern. Because now it's just like, okay, we are merging two arrays that are already sorted, right? So merging two arrays will involve pointing at two different directions, pointing in two different directions. So I need to use a two pointers solution. Yeah, right. This is good. Although I failed, it's okay. We'll try another time. I'll repeat this same question tomorrow and see how well I will explain this. Alright, that's it for the stream today. Um I guess we have to close now. I'll see you guys tomorrow. Thank you.